Okay, we are in a discussion of AWS solutions architect, and we've been discussing different topic of AWS related to solution architect point of view. The previous video discussed about AWS API gateway, and now we are just entering into a few topics which is closely related. That's going to be related to coding, right? So the topics are going to be AWS code build and AWS code deploy, and then AWS code commit, and then AWS code pipeline. So they are all basically more related to developer side, DevOps side. So I thought before I start in those topics, I'm going to give you sort of general knowledge and terminology which we're going to encounter in these few different topics about modern DevOps landscape, right? So repositories to deployment, right? Uh, if I tell you very briefly, right? Uh, to why I want to describe the mainly the terms and terminology in this topic. I think the development side that we call normally coding. Coding has evaluated a lot from 90s and 2000. If you are someone from 2000 or 90s, Uh, you probably remember we've been using a local machine to do coding. Any of these guys should have at least hands-on experience with one of these languages. So we have so many languages came up in those days. Like probably used Visual Studio, Visual Basic, and then you remember we used Java. Possibly, you probably have experience setting up a Java environment in your local machine before you starting coding, because you need to set up all environmental variables in your local machine to make sure the coding's working without any problem, and then use these editors to run these codes, and then you debugging and rewriting and fixing errors, and then finally, when the code is ready, we're going to go to a server environment like final production environment and get it installed in a server environment. So today's video, I'm going to explore some modern, right, modern uh, development process strategies which is changed over the time frame. So we're going to explore the complete CI, that means continuous integration, and CD, continuous deployment pipeline from source control. So source control where we use in a cloud environment. Source, we keep source there, different versions, history. Understand how modern DevOps platform integrate repositories where we keep these codes. Uh, when you call about repositories, you probably, if you have a Linux experience, you probably remember we use repositories to download new packages, new versions of Linux operating system, and you set up repositories to access when you need a new package to be installed. So automation engines and cloud services to enable continuous delivery at this stage. So we're just going to looking into some terminology and looking into how today's developers environment evolved and how it looks like in a point a view of solutions architect. All right, let's go into next slide. All right, so before we going into actually this environment, we we're just going to explain some of the essential DevOps concept explained because these ones are going to you're going to encounter these in my future videos like when I call about AWS code build, code deploy, code pipelines, code commit. So you're going to hear these words more frequently. So let's looking into some of these words. What are the meaning of them, right? So the first one we're going to encounter is webhooks. So webhooks is automated HTTP callback triggered by specific events in the repository, right? So when you have a repository, you're coding, right? So you have this is automated callback, like when you doing a code push or pull request created. When an event occurs, the platform sends real-time notification to configured endpoint, enabling automated workflows, right? As an example, the code push triggers a webhook that start a continuous integration pipeline, notifying the build server instantly without calling, right? So it's something you commanding is going to go, and you sometimes pull request coming back, something like that. So we called it's a webhook, right? It's an automated HTTP callback triggered by specific event in a repository. So the second one is called code commit, right? Code commit is a snapshot of code changes saved to a version control of repository. So you possibly have done one of these features, right? Adding a feature and you save that control version, right? Each commit modified files a unique identifier, timestamp, author information, and commit message describing changes so you can identify, right? Okay, so might be something you have added a feature or might be a fixing an error, you're saying fixing this error, right? And then you have a unique identifier and you have that modified file for fixing errors, and then you have a time information and you have author information and what are the messages describing what you have changed, right? Commits from audit trail of development history, enabling rollback of blame tracking and traceability. So best practice, atomic commits with clear descriptive messages. So makes the in a, that's as a rule. So best practice is to keep clear descriptive message in that commit what has been changed, right? So that is called code commit. And then you going to encounter a word called artifact. The artifact is a package output from a build process. It's like a source code and it's a compiled binaries or can be a Docker image or jar files in Java, right? So npm package, right? Artifacts are versioned, stored in registries or repositories. You remember I spoke about container registry. That means the registry of containers. A repository is also a file, a bunch of files, and used for deployment. Examples: container image in Docker Hub, right? Or Elastic Container Registry, or in a Java artifacts in Artifactory, right? NPM package in NPM registry. Artifacts enable reproducible, consistent deployment across environments. So this is a results of a package output from a build process, like it's a versionized product, right? It might be a container up to this level. Then there's another version of a next level, something like that, right? Okay, so then you're going to hear about something called staging environment, right? So what is this staging environment? The staging environment is a pre-production environment that mirrors production setup. So staging environment has a similar, like a mirrored environment, what you really having in a reality, like in a production environment. You possibly have a hardware OS database dependencies for final testing before release. So it's similar to your work production environment. And there we staging validates application behavior, runs integration test, performance test, and security scan in a production like consist. Issues discovered in staging prevent production incidents. So staging is the last gate before production deployment. So it's a similar to the actual production environment. But before that, we're going to use that one to find out all the behavior of the application, whether it's working according to our requirement, and then is there any security issues are there. So it's before you releasing a production software version. So this is environment you're going to be testing it, right? So that's called staging environment. And then you possibly heard some other word called blue-green deployment. So what is this blue-green deployment? So the release strategy maintaining two identical production environments. So blue means current live and green is a new version. Deploy to green and run a smoke test, then switch router load balancer traffic to green. So if issue arises, instantly rolled back to blue. So zero downtime deployment within a minimal risk. So popular for critical system for requiring high availability. So this is a switch in between two environments. So you have blue environment, which is currently live environment, and then you have another environment, similar facilities with the green, and then you deploy to green, the new version, and then you test, and then you use the routing, DNS, or load balancer, whatever traffic to green, and see whether anything comes up, or if it's running smoothly, there's no problem. But if you're having any problem, so we just pointing all records back to a blue environment to make sure there's no any problem. So it's a zero downtime deployment with minimal risk. So this sort of environment you can do like load balancer and part of traffic going into green environment, and a majority of traffic going into blue environment, and then green environment works fine. Then little by little you can change the through using load balancer to more traffic back to green environment, right? So that is called blue green deployment process, right? And then we're going to be looking into every single minute you're going to hear this one. It's a continuous integration and continuous deployment. So continuous integration is coding automatically build, test, and validate code after each commit. When you do a commit in a code, right? Each time this continuous integration automatically build and test and validate the code. And then continuous deployment is automatically deployed, validated code to production. So CI/CD pipeline eliminate manual handoffs, catch issues early, and enable rapid, reliable release. So pipelines include, so pipeline means the automated process like orchestration. We're going to talk about this one in AWS code pipeline, right? So build, test, security scan, then staging. Staging is before releasing, and then production. So that is normally a pipeline, right? We're going to talk about this one in some more details in AWS code pipeline under, right? The next, we already discussed the containerization. So containerization is a Docker environment. So packages application code, dependencies, runtime, and configuration into a lightweight portable container. So everything, right? Everything package wants. So code, its dependencies, runtime environment, and configuration files into a lightweight, right, portable container which can work independently. So containers ensure consistency across deployment, staging, and production environment, right? Uh, so that's you mean within brackets you have works on my machine problem solved. So long time ago in our traditional method, we using our local machine to testing code, and then you shift into a production environment. It might be a different operating system. Maybe you using a client Windows version in your computer, and then use a server operating system in a production environment. So you can tell it works on my machine. Doesn't mean it's going to work on the server computer. So that part is eliminates with this containerizing process, which carries everything like dependencies, runtime, and configuration files, right? Because Docker images are like identical. So foundation for modern artifact management and cloud native deployment. So enable isolation and efficient resource utilization. All right, so that's called containerization, right? And then we're just going to talk about infrastructure as code. So that is managed infrastructure servers, network databases, security policies using code. So you're going to use like a Terraform, cloud formation, and Ansible rather than manual configuration. So less human error. I think we already discussed about cloud formation. I have intention of discussing Terraform in one of my future video. So they all trying to figure out the environment going to be similar to whatever we testing, and they trying to escape human error, right? So I infrastructure as code enable version control, reproducibility, auditing and automated infrastructure provision, change tracked in JIT, enabling rollback and consistency across environment. Remember blue green? I explained a few minutes back. And then you have the other one, it's a troubleshooting and monitoring. So observability and monitoring the continuous detection, the analysis of system matrix logs and traces to understand application health and performance. So detect alerts, right, and deeper insight enabling troubleshooting root causes, right? So you probably going to use some tools like Prometheus, Datadog, ELK Stack, and then it's going to be CloudWatch in AWS. So these are the ones that are going to monitor and finding out the problems, right, coming up. So configuration management, so centralize and control environment configuration, right? So it's all centralized like credentials, API endpoints, feature flags, environment variables. It's separately from code, so enable different settings per environment without code changes. So these tools are just like HashiCorp Vault, right? And then AWS Secret Manager, environment variables. So they improve security consistency and reduce configuration drift across deployment. So that is what are the basic terms and how they work together. So developer made the code commit. You do a change in the code, and then once you do the change in the code, so webhook triggers CI/CD pipeline, and it will build artifact, right? And then use find a configuration file through that, and then deploy that code into staging for testing. That is a pre-production environment, and then validated artifact deploy to production using blue-green strategy when you need it, and then you use some of the tools, monitoring and observability, continuously watching production health and performance. If something find, then the same process goes back. So you do a code commit fixing that, and then webhook triggers the same process. This is how they work together, right? All right. So key criteria for selecting a source control platform in modern DevOps, right? So if your organization or if you're doing anything related to production of, or you're doing any development related capabilities in your in-house, there are few factors that can be effective if you consider in these factors to find out the best environment for your requirement, right? So they are some of these things, right? So integration capabilities. So you need to think about what sort of um, environment in your office so you're using. So are these your development environment, are they supporting these other factors in your organization, right? So native and third-party integrations with the CI/CD tools, security scanners, issue trackers, right? And then you have any collaboration features like collaboration group can work like Git workflows, right? And then code review tools, line comments, right? So it is uh, going to be used for a team environment, right? Or distributed teams, right? And then what sort of security features you are expecting in your company, right? Right. So you should be able to use RBAC, role-based access control, and then encryption at rest and transit, and then authentication, and you probably looking in compliance certifications, right? And then I go to scalability and performance, right? Then what is the scalability and what sort of performance you are going to need it, and then the next one is a built-in DevOps tool, so it's a container registry, artifact storage, orchestration. So and then again, the last one is going to be like cost and licensing models. What sort of cost you considering, right? Infrastructure, maintaining support, or manage the solution. So decision framework, cloud-based. So it's a GitHub and GitLab based for agile teams, prioritizing speed, integration, and minimal ops overhead. And GitLab is a self-hosted, ideal for organization with a strict data residency, compliance requirement or existing infrastructure investment. So normally, like a teams prioritizing speed, uh, minimal ops overhead. So you can use cloud hosted, and then GitLab is a self hosted, ideal for organization with strict data compliance residency requirement, right? All right, we can go to another one more slide possibly, because it's already 24 minutes we spent. I might have to do this one in the two video, part one and part two at least. Uh, it's a good idea before we talking about code commit, code build, and code pipeline, and yeah, all these code related topics in AWS. Right. So we're going to have a look bit of these different topics, right? The presentation explores the complete DevOps landscape from source control through cloud deployment, below is roadmap of key topics covered. So we're going to looking into some visual workflows, deploying pipelines using GitHub actions, and then complete pipeline stages from source control to production monitoring, and then we'll have a look at source control selection criteria, and then essential DevOps concept, right? We already discussed what are they in source control pipelines, and then platform comparisons. We're going to compare uh, available platforms, available repositories, uh, also in between the major cloud suppliers like AWS, Azure versus Google Cloud Platform, and then the orchestration, Kubernetes native deployment, then a real world scenarios to find out what we're talking about, right? So modern DevOps success depend on selecting the right combination of source control, CI/CD engines, and cloud deployment service aligned with your organization scale, infrastructure, and team expertise. So, as I discussed in the beginning, so these factors are very important when you are selecting which environment is suitable for your organization, aligned with your scale of production and then infrastructure and your team's expertise, right? All right. So we're going to look into basically what we have discussed. So the CI/CD pipeline timeline, right, from code to production. So this we're going to visually looking into how this uh, from the point we started doing coding and then until you getting a complete product in production monitoring, right? So in this picture, it says I'll explain briefly, and then we'll go into each one little bit descriptive. So the T timeline is at the beginning, so developer push the code, and then as we discussed the build triggered, right? CI is triggered, right? To build, test it, and then it's going to run test run, and then it's going to start a security scan, right? It's a long time ago. I remember when we doing local machine uh, coding, we don't have much in a security scan or something. You know, like when we know it's a security hole or something, once we put in production and it's some hacker or someone trying to crack that code, then we realize, all right, this has this weakness or vulnerability, and then we're going to start fixing that one, writing code again, something like that. So then here the artifact is ready, so that product is ready. Either it might be a container or it possibly be a software or something. Okay, so that's ready, and then it will be deployed in a staging. Staging environment is where it goes before production, so pre-production, and then you're going to go to approval gate, and then after approval gate, then going to be production deploy. So you're going to go to a blue-green environment, and then or whether it's not a blue green, so going to be production. And then you're going to monitor the production like using something like a cloud watch or something. So you're going to see how its performance, right? So these tasks are basically explained in here. So the first one is a T plus zero is code committed to repository, right? let's think you something created your account in let's say you did start from beginning, so you might have started from the beginning, and then you GitHub uh, uh, and then GitHub we're going to start, right? And we put a code, and then we commit the code, and then a webhook triggers automated pipeline immediately, and that process is started building the code, and then testing is started, and then build phase. So CI system compiles the code, resolves the dependencies, and create executable artifacts. So it's going to create the product, and then the testing phase. So you got unit test, integration test, and functional test execute in a parallel across the environment. So that's execute, and then this one is a security scan, checks for vulnerability. If build fails, if critical issues are detected, so otherwise it will go and create the build. If this one is successful, so we go into next stage. So the artifact creation, it might be a Docker image or version, or with the dependencies, the product is created in that one, was pushed to a container register with metadata, right? And then that product staging deploy. So that's in a deploy in a pre-production environment, mirroring the production setup. So that will be a stage in deploy happen in that time. And then once it's set up, so you going to go to approval gate, right? Um, so stakeholders approve before production, and then production deploy. Possibly you can use blue green or canary deployment. Canary deployment is different stages, right? It's like for a critical product. Uh, Zero downtime release with instant rollback capabilities. So if you do blue green, if something happen in green, you can revert back into a blue environment with the load balancer, or DNS records or whatever, right? So and develop pipeline comprise what one took hours or days into 15 minutes or less. So I don't know about the 15 minutes or less, but it's going to be faster than whatever we've been doing like our traditional way, right? From a single code commit to running in a production with full observability and entirely automated. So velocity enables team to ship feature patches and fixes in the speed of business. So definitely we can tell these methods are making developers' life easier, right? So I believe this video is for today, and we probably have one more slides. Might be I'll do another one video, one or two videos uh, until the time permits, right? All right. I think this is for today. Thank you very much. See you guys from my next video.